Testing. Okay. Hello. Morning or morning. Good afternoon, Nepal. Um, Not sure if you've been distant, but it's been okay. How have you been? Okay. So today I had. So first off, we're not sure what we're going to have in the end with this project. This is again feature complete, so this is not about the game that I'm. Well, I mean, this is about the game that I'm working on uh, personally, like my project, my hobby. But this is an attempt to make a what you would call a we're calling it a Delta Voxel engine. As unlike normal, like for example, in certain games where you have procedural world generation, you would have a deterministic world, sure, but you would store the data on that world that was changed. In this case, we don't actually store the world's data. What we store are the delta. And when a player leaves, we're going to have what are called columns, have slabs. So slabs is usually what you for voxels. We're not actually using voxels at the front end. Voxels are for the minutia. So we are using voxels just for a very specific purpose. The end result should be that we're going to have a character that can shoot an orb that's going to hit the terrain that we're about to design the architecture of this whole system. And we're going to be able to shoot that terrain and create craters and dig holes that will create caves. Now, this is important because the distinction between the original system that I had written, or let's call it the Valheim system, doesn't allow for caves because they're using a 2D structure. Now, this or 2D plane, and you're just adjusting the values based on depth. So what we're doing is a little different. We're going to create what's like a column of resolution, and those columns work in conjunction with the segments that would normally be there from like how the Valheim system has. But instead, now these columns track the delta, and that delta is what tells us, hey, this area is actually dirty. Things are different. We have a deterministic world and a deterministic delta. In other words, once a delta is made, we don't store the individual bits of that delta. We store the changes that the delta makes. Yes, but we store it as a seed in and of itself. That way, when we're ready when to save the game or load whatever that specific change is, it has a very small place in memory. Um, Otherwise, like if it's not loaded, it's not just sitting in memory consuming megabits of space, right? Now these systems are already way optimized. So there's architectures out there that are super optimal to begin with. I'm just taking it to the bleeding edge of where I can myself bring this, humbly bring this. So I'm going to give this a shot. Let's see what happens. I don't promise a success. This was the last. I'm happy you're building this and reusing ton of stuff from Valheim. Yeah, it's so I think I shared with you the world that I should not world, but the terrain generator that I made before Nepal. Like I showed you the video of it running, I think, or the image. Um, I think it's in this project. Hold on, I think it's over here. Actually, give me a sec. So this was my other project. So someone just wanted to make like I'll run this one. So this is the entire point of this feature complete project, right? I can just create whole environments and just build features for that environment. So in this case, we just have a bunch of gizmos going off. That little red circle is my attack area. If I attack with this by left clicking, it flashes white and it will do 3 damage. These little red guys are enemies. So you notice that my 3 damage is just hitting that guy. Like that, that's just straight damage that I'm doing. Now if I pick this little sorry, if I pick this little square up here, it gives me a little power up. You'll see it come up over here in the debug. And now it's going to, you can't see it, but you'll see the number fly as now these guys will be having fire. With my fire attack, I'll put a burning status effect on them, which will spread across. Let's actually take a look at the scriptable object it's based on. So this is the burn scriptable object. Its radius is only 3. So let's go ahead and just click, and we'll see that it starts to spread across the others. It has a duration of 5, so go. If I go over here and click this guy, you'll see it starts to spread out. Right? But it never reaches this guy. If I increase the radius to like, let's 5, scriptable object. Good. Nope, still too close. Change it to like 50. Right? There we go. And now you'll see all of these guys are now in range. So that was basically the idea behind it. I think 3 was a good number. Actually, let's just set it to 1. See, like how it behaves trailing out. So oh, it doesn't trail out very far. Let's go to maybe 2. Nice. Okay, anyway, let's get focused. Okay, yeah, let's get focused. So I did do the Valheim. I think the Val test is the original one. So let's just load that one up. I don't recall exactly how it worked. It's been almost 2 months since I made it, I think. See? I have some UI thing that was about. I think it's a separate project. Okay. I think we just need to enable this. Code root. There we go. And I think we have to be playing. So this is just a random seed. I can put whatever number I want in here. I think it's a string, actually. But if we hit play, I think our character starts to fall. No, he's fine. Great. Oh, yeah, we were falling. Okay. Hold on, let me move my character back up. Where the heck is... There we go. It's this color because we don't have a material on it. We'd need to apply material. But you can see that it did create like terrain and whatnot. It's kind of rough to see. I can get it a good let me close this and start it again. Any way to apply? It wasn't like this. It must be no materials, or maybe I deleted the material. So isn't what I'm here for. It'd be good to get it to work just the... Can I just make it here? Oh, we can. It's still pink though. So what material is this looking? So you'll see that it creates these chunks. This is actually really useful. These chunks aren't the actual, how do I put this? So like, you'll see like it goes like that. This is the idea behind how Valheim works. They have chunks, and then within each chunks, there are segments. And then within each segment, it just handles its own like geometry. Right, and you can kind of see what's happening over here. But that's basically how Valheim works. We're taking this system, but then taking it to another level today. Idea. Let's not in play mode. Delete stuff. But yeah, you can see it's just one mesh, and we just apply hills and valleys. The next step would be to then put water over these. And this would be a destructible environment. I don't know if we made it destructible. Let's move on. Getting sidetracked. So very first thing is don't want to save our changes. Let's make us a new folder. And this one is going to be for our Delta engine. Call it the Delta Voxel. Okay, we're going to have a couple folders in here. Our scripts folder to start off with. Shaders, materials, and what's the scriptable. No, we're gonna have a couple more. There we go. Scriptable objects. And the last will probably be materials, scriptable objects, the scripts, shaders. Probably I'm gonna just leave this for foliage, just in case we end up needing to like get an asset switch, stuff like that. I think that's it. Oh, and water. But we should probably instead just call this alright. Let's start. Oh, we need one more. There. Need to create a new scene. This will be our Delta Voxel scene. Can unload this. Alright, so we know that we're going to need a couple of things. Let's just start making some objects, I guess. Should we? Not do it that way. Let's make one empty game object. This one is going to be our diorama. Diorama menu. This is going to handle basically the process of visualization, because it is in fact a diorama. So see. Ew, pink. It's not pink, Nepal, it's magenta. Hello. Hello, Moinels fools. There you go. Pink problem easy. Okay. Can I learn about your game? What is your goal? He heard you. He'll get you. Oh. Okay. So, Moinfuls. this is not a game in itself. This is going to be a part of the game later on. This is what we call a spitball session, I guess, for creating, basically taking an idea and then making it real. So in my mind, I have an idea for world generation, and this is my playground for all of my other ideas. So this one is about what's called what I'm calling a Delta Voxel engine. It has a more technical name to it. You'll get bored if I say it. But the idea behind it is we're going to be using Delta events, which, give an example of what a Delta event is. Think of like when you play like a car racing game and they allow you to do like a replay going back. You get to see, that's what's called the delta of that timeline. So we're relying on a delta pattern to create columns for things that the player might have done on the world to minimize the data footprint on memory. That way we can easily call up changes on a terrain and do things like, if the player digs a hole, store that that change happened in the world as a seed. So it's just a series of strings or numbers or whatever. And then we can take that seed, because it's deterministic, bring it back to the game, and suddenly the world is persistent. The player can, but so we have to deal with a couple of hurdles. The pink stuff that I was just showing the initial test that I did of the rougher version of this idea, where I simply just remade. If you've ever played the game Valheim, I just remade their world generation system, parts of it, not the whole thing. The whole thing is a whole lot more, but the terrain. Oh, sorry. I'll turn it down some. There we go. And my mic is maximum, so I'm not sure if I could go any higher. There we go. Okay. Right. So the idea is we can, because we're also storing the delta, we could also do weird things. Like we can reverse time on changes the player made to kind of give, like, let's say you have a spell and that spell allows you to fix terrain, like mending in Dungeons and Dragons. You can apply mending and you'll see the terrain piece by piece come back together. So there's various things that we'll be able to do by exploring this system, this engine. That's the idea behind it. Okay. In the actual game that this is probably going to be in, it is a 2.5D game, 3D world, 2D characters, very high action. It has instance zones, which is what this is going to be. This is not designed to be an entire world. It's more along the lines of there's instance maps that you can go to, and these maps are procedurally generated in this kind of playground atmosphere. Their maps can be small, they can be huge, they can be just a simple house is on the map, things like that, and you go there and deal with an NPC. But that's how it's, this is basically the groundwork for building all of that up. All right. Okay. Let's get started on this. Okay, but I don't promise this will be a success. Again, this is just trying to take an idea and make it realistic. Or make it real, rather. Sorry. Let me know if my mic is still too low. I'll try to figure something out. Yeah, I'm just looking into stuff. Give me 1 sec. Okay, how about now? Am I loud enough now? Not really. I already did it. If you check earlier streams, you can see me goofing around playing it a bit. But I'm just taking another look at the map generation. That's what it is. Like I have a successful way of doing it already, but I wanted to try something that might have fit the initial vision that I had for it more than the one that I ended up with at that time. Trying to make it better, in other words. That's the idea. All right, let's get started with this stuff. All right, so, oof. All right. So let's start with this. We're gonna have to start building our tools up, right? So the thing with these feature complete projects, I start from nothing. So it's just a blank scene. There is no environment besides that Unity provides me. The idea behind this is people who are following along can take these ideas and then go into their own direction with it, do something amazing. I can only do what I can do. But I try to keep the code as generalized as possible. So it's modular. If you're just going to rip certain things, you should be able to just take them out and slap them into your project in some way. That's the idea behind it. Okay, but I promise nothing. Let's see. So we're just going to start creating some empty scripts. So let's go to an empty C# script. What should we call this? Probably data types? No. No. This is going to be our data structures. Yeah, let's do it like that. I think of game dev kind of like when you're building a house or anything else that you're trying to build. You can't tell a carpenter to go fix a chair and then just leave them with their bare hands. They have to have their tools. Game devs, we're a little bit different. Once you have the skill set, like programming or whatever it is, art, music, you kind of have to understand. You kind of, programmers especially, we can just build our own tools. So that's kind of what I'm doing right now. So this data structures class will be I should probably change the name of this to something better. There we go. So this data structures script is probably going to be and we don't actually need this. What we need is a namespace. So let's name this, it's going to be a diorama, or should I stick with? Oh, oops. Let me just make sure things are working right on OBS. Looks like they are. Okay. No. Let's see. Okay, there's a few things. You turn up the mic, the planning. I was going to forget like and subscribe. Okay, thank you very much, Noels. That's nice of you. I have never succeeded in a project before. But you can, bro. Sip up. And also find a game you really this is Nepal. Find a game you are really passionate about. Find out why you like that game. What brings you into it, and then try to recreate that substance. Wayne says, yes, need I am doing one. Can I call you Lone? Yeah, sure. Alright, so we're going to call this a diorama engine. Because it is, as I said earlier, a diorama. So with namespaces, because I have so many other pieces of code just running around, I'm going to end up repeating names of these different classes. So we use a namespace to lock them out of having conflicts with other things that we might make in the future or have made in the past. Right? Okay. So let's start with what we're going to make first. These are slabs. So in voxel engines, they tend to create these to store. They're kind of like positional information. But in this case, we're not going to be using them as positional information. We're using them as delta information. So think 4D. Actually, you could kind of say this is a 4D engine. So let's go system, serializable. This attribute will allow this class to show up on the inspector. It allows Unity to serialize the class properly. Well, in this case, we're making a struct slab. And we'll just do some information about it. So public, let's do like the top Y. So in my mind, I wanted a isometric kind of feel for this. So things are going to have a top position. And while the game itself isn't isometric, I'm going to have the shader give off a feel of isometric perspective. That's the idea. And public. All right, so this is like biome data kind of stuff, but this is runtime biome data, so we don't want to store the actual reference to the biome that this lab is supposed to represent here. We just want it to be as light as possible. Because these are very, very ethereal. They can come and go as the player is there or not there. So these are the initial stuff. We're going to make one public accessor though. We should probably name this like the thickness of this slab. Right? And from here, we can just do the top minus the Y. Minus the bottom. And we have to do a constructor for this. Public slab. And here we'll just ensure that in order to make one of these, you must pass in a bottom, a top, and we want the map and the mat. That's the material that we're going to be dealing with, and bool is water. And we're going to set this to false. Let's see. Do you know how... Do you know... Oh, sorry. Do you know those psh that came in Cola? Damn. Encouraging sip. Okay. Thank you very much. You joined at the very beginning, so this might be a little bit dry until I get to the visualization part, but I'll try to remember that I need to test my code as I go along. So yeah, we can do the mat ID is the mat and is water. Leave it as water. Oh, whoops. There we go. All right, so that's our slab. So there's going to be a bunch of these that store the delta information about what we're working with. We're going to just keep going a little bit now. So slabs, we're not going to really do a lot of documentation here, but slabs basically are the things that make up columns. So now we're about to make the column itself. So these are classes now. Right? So the very first thing is we need a list of slab. And we're going to just call this slabs. Why are you... Oh, I know why. Because you did NUnit framework. So annoying. It's using system.collections. Dot generic? Yep, there it is. Okay. All right. So what was happening here is that the namespace that this needed to be defined by was incorrect. So I just had to change it up there. All right, and we just need to know if there's a game object that occupies the space. Yeah, I set it to null. All right, so this is like, let me mark it off actually. This is for like trees and stuff. That might be like on this spot, on this column. Right? So don't think of, this is what I was saying, don't think of these columns as temporal. Think of them, sorry, don't think of these columns as geometry. Think of them in terms of time. Because this is again a delta pattern system. So we are at a certain time, what was here, and if there's multiple things here, then they can exist, but they would each have their own representation of a column, and what they were doing on that column within that with that slab. Right, that's the idea. So we're thinking fourth dimensions. Okay, so now we just need to have some accessors for the slabs. Let's start with just getting a public bool try get the surface below. So this should return the top Y of the slab, the closest, basically to the top, or where the player could or enemy AI could use to navigate. Right, and then we just do the out float surface. All right, so our surface is going to be equal to float.min value. That means that we just go as far down as we think we can, and then we just do bool found is equal to null, or sorry, false. And now we just go through on a for each loop for each slab. I don't like that. So maybe we are better off. Let's do for loop. Right. And then we can go var slab is going to be equal to that if slab equal to default. Can we do that? Equals operand for the type slab and default. It doesn't have a default. So we can just do this here. Yep, we can't do that. Okay, there we go. Beautiful. Let's see. Encouraging. Nep, call Nick to join because he wanted to ban me from the Roman server. Jump. KK. VU. Nick wanted to ban you from the VU, join chat, like, and subscribe. Okay. Interesting. Let's see. Okay. So we're going to go with it this way. I think this is better. But basically, now we just need to do a check on the if the let's get the slab. Well, actually, let's make our lives a little bit easier. There we go. So s.top y just needs to be less than or equal to the query y, and the opposite is true for the s dot surface for the top y. The surface equal to or, well, I guess has to be greater than the surface, right? Yeah. Then found can be equal to true, and we just break out. Yeah, that looks good. Inequalities are doing unequal things in my mind. All right, I think that's good though. And then we just do a return found. Why are you crying? Oh, whoops. Yeah, all right, we'll do it this way. Right. Okay, yeah, that's good enough. Because it should return the last one that we find, not the first. So let's go through it. So that's one method down. We still have quite a few things that we need to do. What we're trying to build, so what is data? What I'm doing is we have a list, but every time you make one of these, or every time I make one of these, as an architect of these types of systems, you have to give yourself and whoever is coming after you, that could also be yourself, easier ways of utilizing these collections without having to go into them themselves. Normally, I'd even want to make this private, but we want to have access to functionality from within these without really needing to query it itself. Um, or externally querying it itself, right? So usually for this, now the next thing that we want to do is like we want to get like any other slabs around it. These are usually called like its neighbors. So let's do stuff like public list, and we can just get the list of slabs that are nearby. Okay. think. Once I get out of these inequalities, it's going to be a little bit math heavy later, but right now these inequalities will wreck my brain. I need to give me a second. We need this to be greater than or equal to the minimum and less than the maximum. So, but I'd also, gotcha. So we can just do the top y is greater than or equal to the minimum, less than or equal to, I mean, my autocomplete is thinking it's right, so it must be true. Result.add s. And then after that, we can just do turn result. Next is we need a method for like just adding slabs, like a public way to do it. If we make this bool. And we should probably deal with the sorting for this. So slab.sort. A little bit of a anonymous b. And we're going to just do an a. Can we just do it directly? No. Yeah, there we go. All right. We didn't make the method for it to be able to just do it directly, but it's fine. Because it's fine. And then finally, we're just going to have our ability to remove it. It doesn't return. It does return void. Darn it. Okay. Fine. All right. So we're done now with our column. Let's see. Can you still, what am I? Okay, hold on. Let's see. Shocked, huh? Nap, next. Sorry, Nap, you're good. You can still make it private. Return a read-only list. Well, no. We need to, because of the nature of this, we're going to have a generator, and I don't want to put the generator inside of this. It's just there's no constructor inside of a column. We don't want there's going to be a manager handling columns, and that's going to be the thing. That's the reason why we keep this one public down the road. Like otherwise, then we wouldn't like, because if I was dealing with if I was dealing with geometry, then yes, we would do it that way. But because this is a delta system, the value that is here, this won't know what's going to be in it, because that's what the deterministic seed that this will produce is going to know. So that seed is what's going to populate these things later. When the player is like in range of the area, and I don't know, they had a fight there and there was a crater there, or a meteor hit that ground, whatever. But the point is, when the player comes back to that area, it'll load that sub seed, which will then repopulate these columns. And these slabs of pieces are just pieces of time, or the delta, and just re-represent what happened in that spot. That's how it's set up. That's what I'm going for. So we could like do things like rewind time and so on later. Okay, I think we're done with column. I believe we're done. So the last part that we need to do is actually the spatial part now. So this is going to be segments. So let's do that. So I believe this is going to have to be a struct. Maybe it should be a class. I would think in Valheim they used a class for this, so let's stick with class. Public. Let's make a constant out of this, and it's just going to be the constant that represents the overall size of every segment. And we're going with 8. Right? So now we can just do a public vector2 int. There we go. Oops. And we can call this the origin. So this is where this is. And get set. All right. And then we can just do a dictionary now of all of the columns that are in each segment. So this kind of like, it stores its position, and then it stores what happened at its position. Vector2. No. Why would you do that? Autocomplete is doing autocomplete things. There we go. All right. We just want to do a get on this. All right. Again, if there's anything wrong with the audio, just feel free to let me know. I'll try to change things. Torrent on my channel? Why would I need a torrent on my channel? That's it. That would be weird. Does your channel contain any kind of educational content? I would think just about everything in the channel can be educational. It's really up to what you want to take away. I go over... I think the very first few videos that I did were mainly about showing how to create event-driven state machines. And then going forward, but there's no like, I just do live streams. There's no, if you mean to say if there's like a, or mean to ask if there's like a videos of this is a chart of stuff, this is how you do these things in sequence, I have nothing like that. That's like, you can get that everywhere else. I just show how I build things. Like, there's tons of videos breaking it down bullet by bullet, but some people, they get half information from that because you can never truly convey a working system without showing all of the mistakes that you make along the way. Right? If you just see the end result and it just looks beautiful and it works, the only people who really, in my opinion, that benefit from that are those that already know what the pitfalls are. And then they can evolve what was done. But otherwise, it is what it is. All right, let's get back to this. So we made the dictionary. I think we probably want to track the mesh root for the segment, right? Like the root mesh, and if this is dirty. I think that's probably all we need. So public mesh root. Yeah, get set this, and then we probably want to store the public bool. Yeah, and then set this to true. And probably make this get set also. All right, that looks awesome. All right, so we just need to construct this now and give it one method, which is going to give off what its coordinate is to the manager that's going to be handling this later. So let's do a public segment. And, oh, nice. Did autocomplete do its job? I mean, it's giving us way more than we even need. I mean, I don't like that it sets, because we want dirty to be true. You know what? I'm going to leave it like this. We don't want to pass in these things. There we go. Okay. Right, and we just need that bool method now. Public bool. And we just need to tell it the contains coordinate. And when we pass in a vector 2, we just need to know if this contains the coordinates for this. All right, so var local is going to be equal to the coord minus the origin. All right, and then from here we can just do a return. And this is a little bit of math, but we're just going to take the x, local.x, and then we're just going to do a little inequalities with it. So if this is greater than 0, and the local x is less than the size, so local we also want to know about the y, so it's just the same thing. Oh, cool news. Autocomplete knew what I wanted to do after I had done it halfway. So local x, let me just make sure. Yeah, it's fine. All right, so this should create a cube, effectively, as our segment. All right, good stuff. Well, I say cube, but this is the it itself, and then this is the depth right here. Right? So this gets really... I won't explain everything here, but we'll see how it starts out. In my mind, this should be what we need to set this up. I don't think we need anything else. We're good. All right, let's go back to Unity real quick. Oh, I forgot. Here, you guys can have some fun with this. There you go. Enjoy your bombs, Nepal. There you go. Okay, let's get back to it. All right, so we have our data structures here. That's the foundation for what we're building. The next tool that we probably want to build for ourselves is the scriptable objects. So these are going to be the biome information as we go along. So let's do this. I guess we're going to name it maybe biome SO. That's like simple enough. All right, next. Okay, so biome SO. First of all, if we're going to put this all under a nice big namespace from this side, the loving arms of our namespace, diorama engine. Okay, I should probably rename it to, what did I say I was going to name it? The Delta Voxel engine? Makes more sense. Delta Voxel. It is a diorama, but it's Delta Voxel. But more apt name for it would be the Delta Voxel. Okay. Biome SO information. Load that up in Unity. There we go. All right, so we need to know. We need to do. We need to know the height that the range of the height that this biome would try to appear in. Maybe it's materials and like the foliage that should be here if it can have water, things like that. And we probably want to apply its noise, like a scaling for this type of biome's noise. Yeah. Okay. So, let's start by making our UI pretty. Header. So, we're going to call this the height. So we can just do public vector 2. All right. We need the materials. Yeah. We haven't made this class yet, but we're going to make it. Probably going to do one also for the material. I'm not sure. Or should we just use the material? I guess this counts as a... So what I'm thinking about is abstractions. I'm not sure if I should abstract out certain things, so that way I could give them other namespaces, or sorry, other ancestors later, and or like an interface or whatever, and share that. That might make my life easier downflow, but we'll cry about that when we reach there, so let's just do it. We're gonna cry and say I wish I had done that differently. Let's call it a foliage entry. Oh, it's actually a library. Hmm. Yeah. All right, let's keep things consistent. Maybe 6 is a better number. Oh no, we have 8. That's right. So we can just use the no, like int. Yeah. Um. That's better. Okay. Now we're just going to make the foliage entry. It's just going to be a poco, so we're going to do it right here. Not a big deal. So we need a prefab. We have to do that. Public. Right. Um, yeah. Yep, that looks about right. Okay. So this is our scriptable object. We'll create some in a bit, but for right now, this is just, again, another one of the little nails in our tool belt, effectively. Um, let's start from the top level, because this is just the tool set now, right? We have our data targets, so let's work our way up to from the top down to the bottom now. So we're going to make our world generator. So let's get busy with that. So we have this right here. Let's just copy this. So I don't know. Yeah, I think we can just do it plain empty. World generator. And into the loving arms of our namespace we go. Okay. Let's take a look. No, I don't. What? Arabic? Oh, I missed stuff. Wayne Falls has 1. Nep, how did you understand the Arabic that I spoke? Nep understood Arabic? I'll try. Jump. Bomb. I don't know when Nep understood Arabic, but apparently Nep understood Arabic. Oh, he's not owning up to his Arabic knowingness. Okay, Neb. Um, let's see. All right. So we're going to start with our world generator. It needs a little bit of help. So we're going to do, so when you're dealing with world, the very first thing that we almost always in every world generator script that you will ever make in the future need to have is cardinal directions. So we need to create those. Um, in this case, we're going to, you could do it many different ways. In this way, I'm going to do it through creation of a struct in order to get directional modifiers. So let's do that. System. Um, MA. Okay, good enough. And then we just need an evaluation process. Good stuff, I think. So float and x is going to be equal to the float chord x divided by the world radius. And the float and z will be similar. Just the right, and then we just need to gradiate them. So float, let's call it grad, set to 0, and now we can just do grad is going to be plus. We can do math f dot max on this. Yes, we can. And 0. Sometimes Unity likes to make sure I don't use math f. And then we just multiply it like that. There we go. So now we just need to do the same thing for each one. Let's go south. Okay. And finally, we're just going to clamp it. No, clamp. There we go. All right. That should set us up now for our world generator. I'm not sure if I'll be going the full month on this. Like, I might, because this is probably, I started a little bit late because we were doing some debugging earlier this morning. But I think that for the most part, we should. I'll see how far I can get on this today. I really hope that I can show you guys some visual stuff today. That would be really awesome. All right, let's get forward on this. So the first thing that we need to know is the seed. Um, and actually, let's be consistent. Whoosh, 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 mush, mush, mushy. And then we can just do our directional modifiers. I mean, we can just call them biomes. We don't have runtime biomes. Yeah, that's good. Yeah. All right. And then from there we just have the world radius. All right. And then we can just do a private read-only, and we're gonna make a little system that random RNG thing going. Okay. So now we just need to construct this. Let's do it. Public world generator. The idea is, so this world generator is a little bit misleading. What we're going to do here is create a world in the form of data. It's just going to be numbers, and that's it. Run numbers and references also, because we do have references to materials in this, as well as scriptable objects. So yeah. Yeah, okay. So we want to have the int, the seed, obviously. We want to have the directional modifiers. We want to have the biomes. And we want to pass in the radius. Okay. So, should I do... I think we're good. Let's just populate. We'll figure it out when we get there. Seed. Odds. Odds. Biomes. And radius. World radius. Radius. The RNG needs to be equal to new system random. Okay, good stuff. Oh, and we need to pass in the seed here. There we go. All right. So now we just need to do some API work. Let's do that. Public dictionary. So this should look familiar. Vector 2 and... did I do 2? No, I did not. As soon as I start to feel like as if I'm mentally exhausted, that's when I'll stop, I think. Because it doesn't make sense to make mistakes on this, since it's not high pressure to get it done. This very day. Generate world. But I will try to get as much done as possible. We're going to want to pass in an enum here. Alright, so now we do var world is going to be equal to this new dictionary that we're going to make. We're going to want to do that. So we probably have to make world shape next. And we pass in the world radius. Right? So basically it's just going to give us... So I planned on having various types of world shapes. So we could have circles, we could have cubes, we could have octagons. So the idea is, based on what the shape is that we put here, it should handle just giving us the coordinates that would be on the world. That we can generate, that we can help to use to generate the rest of this world. That's the idea. Alright, so now we don't need to worry about this. For this, we can safely use a for each loop. Var coords. We need to make... We do need to make that. We need to make it first. I wanted to just jump straight into this, but I think we need to definitely make the, because it's going to blow my mind downstream. If I don't do it. I'm going to do it now. Let's just do it over here. It's not a big deal. It's super simple. You'll see. It's a super simple abstraction. So just do public, abstract, and we just do class, world shape. Right? And then we can just do a public abstract. List of vector to int, get coordinates, radius. That's it. So now we're just going to have a whole bunch of things that's going to inherit this later, but for right now, this is done. So this now gets us our world shape and our get coordinates to work. Told you it would be super fast. Oh, let's get back to the hard part. So we can now do a for each loop. So we do var call is going to be equal to generate a column. We're going to make this in a second, and we'll pass in the coordinates. Yeah. And if the color is not equal null, we don't need squigglies for this. It's just one idea, so we just do world call is equal to that. All right, no, we're not done here. We're going to also have a method for carving out rivers in our system. Just pass in the world here. And yeah, we just do a return on the world, I think. Maybe we'll add other things here later. But for right now, we just want the ability to... This is just terrain, and then we're carving the terrain. And then when we go to populate this with rivers, it'll just follow the track that we carved for it on the terrain. That's the idea. So the hope is to be able to create like waterfalls and stuff like that, and then when we apply the delta to it, the changes to the terrain, it can then do a recarve of the river along the way, and then just update the river's position. The water will just move to that. The mesh for the water will just move to whatever position makes sense for itself later. That's the hope. Or we can just do a recarve, because this is doing a calculation based on the density. And if the density is better in another area, it'll carve in that other area for the river. So that mesh for the river can now change and go that direction instead. Things like that. All right. So let's first handle generate column. All right. Private. Going to be let's see. Let's check chat. Nep, you know Arabic? No, I don't. But somehow I understood Arabic. Yep, we saw that. Slots. Back again. Welcome back, Moin. Allure. Allure. Not sure what that allure means, but allure. Already. Or alright, I guess. What is it, Lone? Bro, you have 40 VU? Okay. Okay. It looked good. What's up? W stream? Hello, Illusory Moon. What's up? Cool name. Okay, so we're gonna generate a column now. And basically we just add each column to it. Like, we're keeping it simple for this part. The math comes a little bit later. It won't be too bad. I've managed to figure out how to get around certain Walker patterns that we'd use for this, and we'll see. We'll see where it leads. I promise nothing. I promise absolutely nothing. Okay. So we need to pass in the coordinates. So let's vector to coords. So we need to do a blend. So float, dir, blend. This is where our little evaluate pattern over here comes in. So now when we're creating the columns, we can do dir mods, evaluate, and just pass in the coordinate and the radius, world radius. All right, and that'll give us the blend that we need for this column. Float, we're going to now apply some noise to it. And we can just do fractal noise. And we can just pass in the coord. Coord.y. Can we do this? Oh, the octave's missing. Did we store the... I know we did the octave somewhere. Where did we do the octave? We did the octave... I think it's over here, isn't it? Yeah, it's in the SO. Do we already have the SO by the time we get here? I think we need to do this after we do that. We need to generate an octave value. Why does this need an octave before? All right, let's just put in one. Public class. So we're doing new. What the heck? New fractal noise. What are you crying about? Cannot implicitly convert... Oh, the... Oops. There we go. Reading is fundamental. Can we just do it this way? Let me check this again. No, it doesn't have any static calls. Okay. Okie dokie. Interesting. It doesn't have any. Okay, it does not have what I thought it would have. So let's look at it a little bit differently. So we want fractal noise. How are we going to get to it? We're going to have to write our own noise? No, we can get noise somewhere. In Godot, you use speed noise, but Unity uses something else. What is it again? This is where we just start typing and seeing what our IDE gives us. And it's... Hold on, let me get rid of something. Stop. Alright, let's do it now. Because it keeps giving me stuff from that library. Some particle, noise quality, fractal. Oh, I forgot about this. I don't know if this is what we need, though. But there is something in math, I believe. It might be in Unity. Math, F, noise. There it is, Perlin noise. And we can just pass in the chord X, chord Y. There we go. And now we can get a float out. Eventually we find what we need. Sorry about that. It had a good flow for a minute. Alright, back to work. So, once we... so the idea behind this is these columns don't... So the columns represent a space that exists temporally. So once we call back to the seed that is going to regenerate the world, we're checking the columns to find out at the second that we're trying, or the moment that we're trying to recreate the world, what was the column saying at that point. We don't have to worry too much about that. It's just about the deserialization from the seed's information. That's what makes it super lightweight, or it's going to make it super lightweight on memory. So let's just keep that simple, right? Height mod is going to be equal to the math f lerp, and we will go from 0, 1 f on this, and we'll just use the dir blend. That's the idea. Did I type that right? Nope, I did not. Height. And then float. Height. Keep forgetting my T's. There we go. So we just do the noise plus the height mod. Okay. That's a setup, so now let's do some messy stuff. I missed some stuff. Okay, hold on. Let's start from this. Sup, W. Okay. Okay, it's good. Nick says, hello, Nick. Welcome. More like not Delta Voxel engine. We'll see. No need to be pessimistic. It's going to be there. The, hello. Oh, oops, I forgot. Here you guys go. Ha 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 ha. Enjoy. There you go. All right, that's my mental break. So we now need to select a biome, and that should be pretty easy. We haven't made this method yet. But we need it. And we can just pass in the height, and that'll target the biome that we're looking for. We'll make that one next. So we have to carve rivers and we have to select a biome. Oh, As we program, the more we get done, the more we have to do. It's funny. Okay, so if we can't find a biome, we should just stop here. And we can just do a return. Return null. There we go. Otherwise, we have some small stuff to do. So first, let's do the world height. Math f dot lerping it. We need the biome height range. So we're just reading off now, basically. There we go. There we go. And then we can just adjust the world age, I guess. Kind of already knew what I wanted. In this case, I think max would work better. All right. And for the column, let's just do var at this point. I'm starting to get tired, so just bear with me. We're gonna just do var at these for these new stuff. Column is going to be equal to new column, and we're just going to do a var byte. Oh, we already know what this is, but we can't use it. Okay. Let's do then like this. Byte mat is equal to. Yeah, that's fine. Yeah, and then we can just add a slab. Yep, there it is. It's starting to come together. Slowly, it's starting to come together. And then we just pass in the byte ID, and that's it. Yeah, that looks good. All right, we're almost done. We just need to make a final pass for water inside of the generation of the columns. The columns don't handle um, it does the column the column generation part doesn't handle the minor details of like well, not minor, but navigation and stuff, but the column itself has that information. So and it can derive that on itself. So we can just do if the biome has water. Yep. Um, yeah, that's it. Call. So in this case, we add a new slab about water. So the world H. Okay, and that's the. I mean, we should. Yeah. And set this to true because it is water. All right, and then we can just return collider. And now our generate column should be working, but it isn't. Why not? Ah, what did we do? Coordinates. Yep, there we go. Okay. So we still have to do carve rivers and select biome. As select biome is super easy, but carve rivers might be a little bit much. And I don't like the idea of using Perlin noise. So we're going to make our own fractal noise system. I think that's what it's going to have to come down to. So let's do that. So we're going to get rid of this. If you're following along, I apologize. We're about to just get rid of this part altogether, and we're going to replace it with a fractal noise. So let's do that now. It's supposed to return a float. We call it fractal noise. And we'll just take in our coordinates. So these are float x, float y. Well, actually, because we're in 3D, this is RZ. Okay, so first we need to get like our, these are our constants. So float, the sum is going to be equal, or I shouldn't say constants, these are our initial values for this. The amp, the frequency and the max, so they usually, oh, yeah, let me just, it's not open, is it? Of course it's not. Okay. Frequency is going to be, and float, max. So let's change these values up a little bit. We're going to set this one to 1. We can adjust these later, but 0.5 usually good for this. And we'll leave everything else at 0 just so we can give a test to what this looks like when we start producing the mesh. Let's give ourselves some octaves. Int. So we can go to biomes. Length. If that's greater than 0, then we can do biomes. 0. Noise octave. And did I do it wrong? Noise, oh, it's noise octave. There we go. Okay. And we need the persistence. So float. Illusory says, is this C#? Yes, this is C#. Evil AI Romaleko is unleashed on Roman's Discord. I'm not sure what that means, Nick. What's happening over there? Illusory Moon, yeah. I think that artificial intelligence has gotten out of control, Nick. He wants to hit me. He wants to hit everyone who doesn't agree with him. Just like Roman, 1-to-1. Why do I see 46? Oh, wow, that's quite a few people. Yeah, there are. What do you think about the Google effect when it comes to programming? Describe it. What is the Google effect? I mean, I have an idea of what you mean, but please elaborate. Did one of you like bot 20 people, 40? Because it doesn't seem too real. Yes. Why? It looked not. Even me and Nep had this happen to us. I don't know. Yeah, who are these other 40 viewers? What is even happening? They seem very not real, visual only, YouTube bots. Nick says, and they'd come here. Why? Nick, magic dust. Moon going to see me. Illusory Moon has won 10. So missed a ton of chat. I'm gonna just move down a bit. Jackboy Games, welcome to the stream. Have you thought about using sparse voxel octrees? We're kind of heading in that direction. We are using sparse voxel, just not octrees. We're using the delta instead. Uh, is the generation going to be multi-threaded? No, we're not going multi-threaded. There's no need to go multi-threaded because we're just deserializing from it. So we're using a world that's already there. It's not a massive world, but this should be able to facilitate a massive world since we're maintaining it over an X and Y value. But the delta is what stores the more complicated information, and we're going to create the linchpin of it, Jacka, is going to be to create a deterministic, let's call it a seed, that at runtime you can take that seed to then recreate the delta at any given moment. Right? Which means that now you can iterate through that seed to effectively degenerate or generate sections of the world at a time. That's the idea behind it. So, for example, if the player decides to dig, they're doing a generative process which creates a delta. That delta, once they're done, doesn't need to know about the delta between when they first took the shovel and when they finished the dig. It just needs to know when they finished a dig, the delta of when it finished a dig. It collects the delta along the way, but it just needs to know what the dig looked like when it finished. And it can, because we already have the seed, or just the world as it's in its natural state, we can backtrack the delta going back to the original state um, through the seed that's created. That's the idea behind it. Right? Which means that then you can just apply any other seed and it should be able to parse it to create a new subsection of that part of the world. In short, the rest of the world is not being loaded or unloaded. Um, and I don't mean visually, I mean data-wise. It's not being loaded or unloaded. It's just not there to load or unload. It becomes there when it needs to become there. It's kind of like a JIT, in other words. Well, it's JIT combined with AOT. All right, let's finish this. So we need to do something for the persistent. Let's call it persist. Make our lives easier. So the biomes, same process here. We just need to make sure that we have stuff in here. And if we do, we just use the same thing. Biomes. Okay. And then finally, we just do the offset seed. So float. Okay, good stuff. All right. So now we can go ahead and apply Perlin noise because we have the basic definitions here for it. So this is more determinative in a way that I can extrapolate. Right? Because we know what those numbers are going to be. We should probably just make these constants, to be honest, but it's fine. For so we could do the sum plus equals math f Perlin noise. There we go. Multiply that by the frequency. Okay. Are we good? It looks good. Okay. Z plus the print Z, and we just multiply that by the frequency also. Right, so that'll give us what we need. We just need to add in the amp and the frequency. Now, we missed something. What did we miss? Oh, I got you. Amp needs to just do a times persistence. Didn't I write? Oh, whoops, I wrote it wrong. Yeah, we're starting to get a little tired, but we're good. We're almost done. I'm gonna try to get at least a rendering out before I call the stream success. So we're gonna return the sum slash max. Okay. And then we just replace this with fractal noise now. Yeah. I like this better. I like this a lot. Okay. Let's do this. Yeah, this is much better. All right, so let's just do, it's a simple thing to just select the biome. Public biome SO. So we just need the height. I think we normalize it. Let's just double check that. Where are we getting this again? Noise. We don't normalize it. But the height mod... Oh, yeah. Okay. Yeah. We're good. We are good. We are good. We're good. It's normalized. All right. So first we're going to do biome. Biome is going to be equal to no. And then we just pick the best biome. So let's go with best score system here for this. And I guess we can just do a float min value. So the one with the closest score is the one we're going to select to be the biome based on the height that we're passing in that was normalized above. Oh, and this needs to be, we don't need this to be public, private. There we go. Private. Yep, okay, we're good. The only thing that we need to have access to in this, I think, is going to probably be generate world. I think I'm going to separate the reconstruct world, which is the linchpin of this system, into another class. It's actually going to be super simple to set that up compared to what I'm doing now. This isn't hard, it's just a bit lengthy, a bit dense. Okay, so for each, I at this point I'm I'm in that state where I'm just trying to get it out, biomes. But I'm pretty sure we're not making mistakes. Said the guy making mistakes. Float is going to be equal to the b dot height range. Dot make this the x and the other one the y. All right. And then if kind of coming off of a cold also, so that's probably messing me up a little bit. So if the normalized height, guess what we have? More inequalities. So it needs to be. I swear, I'm 100% certain I made a mistake somewhere. If I made a mistake, It's in here. One of these inequalities is going to catch me. They always do. Float score is going to be equal to the normalized height. Right, and then we can just grab the best score. So if the score is greater than the best score, then yeah, we can just set the best score. It's going to be equal to the score, and yeah, best. Biome is going to be equal to B. Yeah, there you go. Okay, I think that's good. That looks good. All right, and then outside of this, we can just do a return, and we can just check for the biome. Can we even do that? I don't think we can, because... One sec. We can't do that. So we can't do this. I've run into it several times. Null coalesce doesn't work on scriptable objects or any Unity object. Any object that inherits Unity object, it says nay. Let's see. Okay, so then from here we could just do biome, and we try not to pass null, so we should just do biomes. Yep, okay, fair. All right, good enough. So this is our select biome, and so now we just need to start carving rivers. So that's the last step that we're going to do here. All right, so to carve rivers, we don't really need much. Oddly enough, this is pretty simple. We do need to have a helper, a couple helpers. I say not much, but I think this is going to be the densest part of this class. So hold on to your hats. Let's start. For this, we should start with maybe... We need to do a little bit of reading. Okay, we're gonna need to... We're gonna need to take this slowly. Let's just do it. If it screws up, we burn it. Okay, so public void carve rivers. All right, and we can just take in whoops, we can just take in the dictionary vector to int, and it's going to have the biomes SO. I don't need the biomes SO. It's going to have the columns. There we go. And it's named world. Yeah, I think that's good enough. Okay. So we need a deterministic way of crafting these rivers. We're going to use another thing that's basically going to live forever in infamy. River RNG, which is going to just be system.random. Do new here. And so we're just going to pass in the seed. Yeah, we're just going to pass in the seed, and we're going to do a little bit of hex. Bear with me. So it's a DEA call, and we can do DEAD. All right. So I don't know if anyone's going to recognize this, but it's a trick. There we go. I didn't pick it up. Why not? Is it picking up on it? What the heck is this? What did I make a mistake on? Let's check chat. Let's see what they know. Let's see. How? Holy cow. One of slots. That means I made... It's fun to play with. That sounds really neat. Hopefully Unity doesn't kill your performance from their overhead. Have a good one. Take care, Jackie. Or Jacka. I don't think it's going... Unity is going to, by the way, if you're still here. Mainly because we're not using Unity's objects for a lot of stuff. So we don't need to worry about Unity's overhead in this case. It's just going to be one draw call on the entire world. That's basically it. When we're dealing with the delta changes, they basically create the visual, or they tell the visual. In other words, in that single part of the area, it will redraw the mesh because we split the mesh into chunks. So that chunk, or that series of chunks, will continue to have a delta. And that's how it works. Goodbye, Moeen. Take care. See. No, you said goodbye before, right? I was saying goodbye. The chosen amount must have... Oh, I see. You guys are just playing shenanigans with stream elements. Gotcha. All right, let's try this. What are you crying about it? It can't convert this? Interesting. This is a new one for me. Give me a sec. Okay, so does this take It needs an int. That's what it is. Negative. I could have sworn this took double and long also. All right, so we need to convert it to an int. We don't really need this here anyway. We could just like use this, I think. For now, we'll use this, but let me make the note. I need to come back to this later. Okay. All right, so the amount of rivers that we will have in this that we need to carve for. So var river count. Sorry about that. That's just a prelude of the struggles to come because this part's going to be a little bit. I say it's easy, but it's never. No. There we go. No, there we go. Can we do it this way? No, we could, but it's pointless to do it that way. It's a little bit more wordy if you do it that way. Yeah, that's good. Yeah. Yeah. I think we should just multiply this. Okay. Let's change this to that. I don't think we need anything. If we get this, we don't do anything. So let's just break here. All right. Well, far. I need to write this quick because my brain is starting to fry thinking about what it's going to do. Easier if I just write it. Yeah, I should. So this is the part where we... So what I'm doing here is the values that are related to this column, I'm depressing them a little bit. This is the whole carving idea. So we're kind of looking at the center point and then depressing it. Once we depress that, then, or bring it down a level in its Y a little bit, the neighbors will pick up on that there is a depression from this and then depress themselves to match what's here. In other words, smoothing themselves out. So that's the idea of what we're doing here. Then it applies, it not applies, it keeps the noise from the previous call. All right, so right, it's bottom first, and then, hold on. Bottom, top, mat, order. Okay. All right, and then, so now what we do here, we can assume that once we've gotten here, we are making a river of some sort. So instead, recall, we don't actually put like the mesh for the river here. What we're putting is a slab for the mirror. So when time comes for us to read, we can say, oh, there's a slab for water here. And we will put that in that position. That's the idea. Because again, this is what makes this work is that this has nothing to do with rendering yet. This is just the information that is the ground level for the rest of the game, right? Or what will make this work is that it's like that. That's what it's doing. Okay. Um so after this I'm going to read the chat after I finish this method. Uh give myself a mental break. So we need to we need to have the water slab come in now. So float the water top y is going to be equal to the coal slab. And we can do calls the same one. It's top y. Multiply that by 0.3f. And that should be a good number. This number is just based on fields. It's not really based on anything. It's just, I think it's going based on just like the amount of carved space I gave this. This feels like a good place to put it. So it's like kind of going to be in the ground at its bottom, sort of, but still above ground or above the carve. The arc, the end of the 90-degree arc that's going to be created from the carving. Right, it's like it's right at that edge, a little bit below it. Okay. All right, we can just copy paste this at this point because we're kind of just typing it over and over. There we go. So we just need the top Y from this. The W top Y. And the setting this to being true because this is water. Oof. Almost there. We're almost done with this method. So this is where now we want to. This is my personal flourish to this. I wanted to try to make waterfalls. So this is kind of going to be where we try to do that. So we're not going to do it inside of this script. It's going to get even longer than it already is. So we're going to do something like this. If the previous top y is greater than the top y plus 0.5, then we will tell this to place waterfall slab. Pass in the world, pass in the current, pass in the top. And I think pass in the previous top y. Okay, that looks good. That looks good. All right, and we just need to update the previous top Y. Right? Um, and we need to update the current. Isn't the RNG here? Oh, random. There we go. Okay, so let's rechat. Let's take my mind a bit off of it. Uh, Blacklist. Why are you blacklisting Steam avatars? I think he's. I think they are at a higher level than you, Nick. Leaderboard. I disagree. I don't need to read. Fair. How? Leaderboard. I don't understand this command, it seems. Um, I mean, it shows. It just shows, I think, a little bit later. Change stream element bet 1131 green. Is it? It shows an amount. Oh, I see what you're doing. Okay. I forgot to sleep. Bye. All right, take care, Moine. I will sleep instead of you. Yeah, I should go too. I didn't get much sleep yesterday. Neighbor came in and said, "Oh, I locked myself out of my phone and I don't have a PC." And that's 3 hours went by. I will sleep instead of you. Updating iOS. Gladly take my sleep. Okay, bye. What's up with Catacomb Crawlers? Did you eat it or something? No. I spent this morning debugging it. Like we spent. Nick. I spent incredible amount of time working on that project. It's almost done for the most part. Like it's coming out. So how do I put this? The game right now is our back end for that game right now is in a good place. I could make it better. I have been working to make it better. I just need a moment to get my brain into a different project than Catacomb Crawlers because I've just been doing that too much. This is that other project. In fact, the feature complete stuff is just all the stuff in my head that's just been buffering for a while, and I need to get them out. So I'm just doing all of these different things because I have to. I have to. Programming is as much as an art as anything else. So I have to do these things. I have to flex these muscles, or else I'll go crazy. So, and I'll get no work done. So with that, I just stop to do this real quick. Um, and then when I go back to Catacomb Crawlers tomorrow, because I was doing it this morning, but when I go back there tomorrow, I'll probably have, yeah, sure. I'll probably go. I'll probably have more insight into the different options that I have. So, for example, right now I got combat down so that each call to it is happening, usually costing us 0.8 milliseconds per call. Super useful for because it's a hot call, right? Like we're calling it all the time for like updating enemies, which allows you to progress quests. But here's the thing, the pattern that I developed within that is something really cool, and I still need to wrap my mind around how I did that. So now I can take that pattern and apply it to other areas, right? That's what I mean. Like I know what I did, but to take that same pattern and then repeat it in other areas of the back end to get it to all flow super, like being able to have 10,000 players with almost no bandwidth or compute cost would be incredible. And that's the kind of thing that I'm shooting for. Right now I have it where we can have 10 players and I don't even see any bandwidth use at all. Like for the last week I haven't seen any bandwidth use, and those 10 players have just been hammering at the game finding bugs all over the place. Like they're trying real hard, and the bugs don't necessarily mean like programming related bugs. It could be something like we intended for you to keep certain information on your UI, and so when you left that UI and then came back, you as the player might not have remembered, hey, I clicked to see the weapons only, and you just like fused an item and got an armor. You came back and now you're like, where is my armor? It's because you still have the weapons selected, kind of thing. So these types of little catches also need to be made to make sense to give the game a good feel for the player. Um, on my side, though, it's more about just getting all of the costs as low as possible and making sure that we have no game-breaking bugs. Um, that's really what it comes down to. Like, and we've hit almost all of them. Like, it's getting to the point where we're getting maybe one or two game-breaking bugs every time we do a build now, which is really good. People are just going around, they're testing very strenuously different things, but it takes its toll. Like, mentally, it takes its toll. So I just have to take a break from that and do something else for a second, and then I just go right back to it. That's the long answer to your question of what's up with Catacomb Crawlers. A date for a release, if I could give it, I thought it was going to be released this month. It would have released this month with problems, but I think it's coming out either late this month or early next month, is what I would say. It depends on a few things out of my control. But every delay that we get, I mean, I'm using that time. You know what I mean? Like, yeah, to make the experience as solid as I can without bankrupting the freaking company. Like, that's what I'm trying to do. Um, okay, so that's my little break. Let's go back to finishing carving up. So we now have all the methods up here done. The next part is going to be we need to write up our get column. Why? We need to finish up our waterfall slabs. So this right here is just carving the path. So we get rid of any ground that we want to have where the river is going to be. And then this is going to build a river. And now we're going to add waterfalls in certain places. All right. And then we also have flow downhill. So this is going to be basically how we cut through things. Actually, let's do flow downhill before we do the waterfall. Like go down before we go up. All right. Private vector to int flow downhill. Yep. Okay. So we're going to pass in. This is not the start. This is just the position. Okay, so vector 2, this should look familiar to anyone who's ever done this before. So we're going to go neighbors. Yeah. Hey. Yeah, we're gonna do this get column soon. I should just call it RNG, shouldn't I? At this point, it's like it's in my head. Yeah, let's just call it RNG. That's what it is. Yeah, I think that's the order. I forgot if it's going to pick up on it in that order or not. It might as well you just multiply the whole thing and whatever you get, you get. Okay. Yeah, okay, we're good. Next. Next. I want to hit this get column thing, but we're not there yet. So let's do the waterfall now. It'll make sense once we do the get column thing. Like, this... I'm buffering. This thing won't let me click this. It's crazy. There we go. Like, the tooltip kept popping up. No. It's the low. Yeah, there we go. Let's just double check that. Place waterfall slabs. Okay, you're good. All right, this one isn't too bad. Right? We just need to do like 2 checks on it and then add. So if not world panes. Yeah, and then we can just do call add slab. And we could just do the low Y, high Y, 0. Oops. 0 and true. There we go. Done. So there we go. That just will add our waterfall. Because this one wasn't too bad. Finally, get column Y. This has supposed to be returning a float. Get column. If this is not making sense, basically we have a dictionary that has a vector2 int. This is something that we made really early in the stream. These vector2 ints are kind of our data grid for all of these different columns. These columns exist temporally. So at any point in time, they're converted back from a seed, which is what we're going to make if I can make it next. But basically, we convert this to a seed and then deconvert it to a seed when the player is nearby. But it'll allow for the things like digging holes and all kinds of weird stuff that you could do. That mimic a voxel kind of world, but is actually a 2D plane. Or a single mesh, 2D mesh. Yeah, I'm getting tired. All right, this class is done. Or, yeah, this part of the script is done. Holy cow, I think I'm going to have to split this up. For sure, for sure, for sure. This is quite a bit. We still have work to do here, though. You know what? Let's make the last part of this world generator the thing that this is going to need. So we have this abstract world shape. This doesn't do anything. So if folks try to like start with what I have here, nothing's going to happen. So I'm going to just make the rest of this in order for this everything that we've done so far to work. Going close this. So that would just be adding in a couple shapes here. So let's add in a circle shape and a hexagon. So it would be public. Oh, circles. Circle shape. Right. And all we have to do is just override this now. So public. Why doesn't it pick it up? Why isn't it picking up? That's weird. Sure, whatever. Actually, we're going to start with... Okay, we gotta do it this way. I don't know why I was trying to avoid it, but whatever. Yeah, that looks alright. Alright, hexagons are going to be a little bit trickier. Huh. Let's check what chat's up to. Makes sense, makes sense. Okay, bye-bye, Magic Code Man. May the evil knife guy not stab at you evilly. Alright, take care, Nick. Have fun. Have a wonderful day, brother. Alright, so let's plug into hexagon. Hexagons are, they're trickier, just because I don't really recall the math behind them that easily. They're not too dissimilar from circles, though. We'll figure it out. Let's just copy paste some stuff, though. So, we know that we're going to have 4 let's call it the quart and right. That'll be the inner radius, and we can just do the I must have made a mistake there somewhere. Let me just double check it. It looks all right. That looks all right. Looks okay. Okay, we'll find out if it's broken later. But so yeah, this is basically completed. Uh, what time is it now? Yeah. Okay, so I'm gonna call this part one. So let's just do a brief look over what we accomplished. Sadly, we didn't get too much into Unity side stuff, but basically, let's update our Unity. So basically what we have here is the data structures. These are our slabs and columns, and the various data or ways to access that data. We have our biome here, which we're going to plug our materials into next time. I think I'm going to probably ask some prefabs, some trees from somewhere else, whatever, just for the foliage when we're ready to add those. And we did the world generator. I knew it was going to be a big script. I did not think it was going to be that engrossing. If there's any need, I'll give a moment. If there's any questions about that is needed for me to go back over, let me know. But I think, holy cow, my brain is like fried right now. So I'm going to call it. Let me see if, give me 1 second. Let me just get some water. Maybe after drinking something, I'll water break. Have a bottle of water next to me and never drink it. Okay. There's no real reason to kill myself over this. So according to, I mean, my blueprints, basically what I want to do next is the world delta and the segment manager. But the segment manager, the notes on it are huge, so that's going to be a big one. The world delta should be a little bit lighter to do, but it's basically the backbone. World delta is the backbone of this. I mean, all of this is the backbone that I'm building, but it's basically the magical thing that's going to make things like reverse time and go forward in time and stuff like that. Um, Yeah, let's call it here. I'll try to stream tomorrow the rest of this. If I start earlier, we can get a lot more done. But it depends. If we have a lot of bugs that I need to hit in the Catacomb Crawlers game, then it's going to take a little bit longer, obviously. But thank you all for joining. I hope that was educational and informative. Um, Hello, Spider-Man Lift. You just caught me as I was heading out. Uh, if you want to know what this is, it is a, I guess you could call it a del. You know, there's a technical name for this. I'll use the technical name once. It's a little boring. This is an event source procedural voxel engine. Uh, what that means is that it is using, if you ever played, okay, let's use a game like a racing car game. A Minecraft. Fair enough. Uh, if you ever played a game like a racing car game where you can go back in time and watch, or not back in time, but watch a recording, right? Any game that you've ever had to watch a recording, they use what's called a event sourced system where they're checking various events, and that's the source of what is rendered. Um, the backtracking through those events is what allows the playing through or the going back to. So we're using that kind of system. This means that we don't actually put things in the world in 3D space. We put them in a space of, did they exist at that period of time? And if they did, then we just show that period of time. So what that allows to do, because we have a default seed for the world, we can then just store, instead of storing the actual world, we can just store the delta itself, the place time, which we do normally. But we just don't store it spatially. We store it like temporally, I guess you could say, right? And that then allows us to say, okay, 1 is a temporal point that we have, the delta that we have. The 0 would be the world's original seed. So now we can apply a slider to that and say, okay, we want to slide closer to 0, and we can reconstruct the world going back like a playthrough, as the system will try to put things back together in a position that they would have been at that phase in time, going back to the original state of the world. If that makes all sense at all, right? So I'm hoping that leads into pretty cool effects later when we get the meshes going and stuff like that. We're going to have at the end some attacks. There's going to be 2 attacks, basically just shooting orbs or spheres that should carve the world. One is going to just hit the world and create a hole. The other one is going to hit the world and dig a little bit before it disappears. Okay, let's call it here. Tomorrow I will work on the segment part of this, which are the manager sections. And the managers are what's... So we spent this one making the data set stuff. Tomorrow is going to be, or if I stream tomorrow, it's going to be the managers for that data. All right, have a wonderful day, folks. Stay up, stay blessed.